Welcome to the lecture on residual stresses in welding. So, we will talk about the welding stresses and typically about the residual stresses which is developing in the welding process. So, as we have seen so far we discussed that during the welding you have the welded specimen is subjected to thermal cycling, and because of that because of the development of temperature gradients, so internal stresses are developed. So, residual stresses are there inside the specimen, and these stresses are many a times as we might have studied that some stresses are good also for the body and some stresses are not good for the component. So, we will have some discussion about the definition and concept about the residual stress development, and also we will talk about the type of stresses which are there inside the body. So, let us first of all see that when we have the inherent local non-uniform heating and cooling cycle which is there in the case of fusion welding. So, in those cases the welding process result in complex thermal stresses and strains. So, you will have certainly you have the heating as well as the cooling, and most of the time it is that it is non-uniform. So, in those cases you have basically the generation of thermal stresses and also strains, because when you have heating then you will have the expansion will go on, then you have cooling, then you have contraction going on. So, that result into stresses development and all that. So, now this is so that may develop the residual stresses, and then these stresses also typically go and result into the distortions in the welded structures. So, why they are important? Because many a times these residual stresses they will be reducing the service life of the structure, because once they are locked in and during the service there may be catastrophic failure, or in normal case it will be decreasing the life of the specimen. So, coming to the residual stresses. So, basically as we see that residual stresses are the stresses which remain within a structure when all loads or reactions are removed. So, basically what happens that the forces which are there, so they are basically balanced within the body. So, they must be self balanced within the structure. So, basically there are few points that it is in the absence of external forces which are causing them. So, these are those which are existing within the body, and they are in the equilibrium within the body. So, that also so it will be representing the storage of energy within the body. So, what happens that if and also they are elastic in nature. So, what will be happening that when by some means you are trying to remove these stresses. So, it will go to different states. So, suppose you are subjecting the specimen to some heat treatment, say annealing or so. So, it will be coming to the different equilibrium state, and the new equilibrium static equilibrium will be stored when you remove those external means. So, the stresses which are still there, so that will be the residual stresses remaining. So, normally we try to remove them with certain means. We have talked about few methods how to get rid of the adverse effects of the residual stresses. Then as we discussed that this is it will be representing the storage of energy within the body. So, in the body have there is storage of the energy, and also they are elastic in nature. So, although they are generated because of the plastic deformations, but they are normally elastic in nature, and they may be released by all the operations which they which release the elastic deformation with a consequent dissipation of elastic potential energy stored in the material. So, in that you will again come to a new state and you will have the set of the new residual stresses in the material. So, that way this defines the residual stresses. Coming to the types of residual stresses. So, residual stresses are defined as macro stresses as well as the micro stresses. So, macro stresses are developed by the inhomogeneous plastic deformation from external loading or non-uniform heating or by varied chemical diffusion. So, basically they are on the larger scale, that is why they are known as the macro stresses, because they are on the large scale, and that is why we look at a larger perspective because of the inhomogeneous plastic deformation which occurs during the welding. So, you have melting and then you have the plastic deformation also at that particular high temperature. So, that is because of the non-uniform heating and also because of the external loading. Also, as we know that in the case of welding, you have the varied chemical diffusion. So, or alloying, you can say, especially in the surface zones you can see them. So, the example of these macro stresses is the flexural stresses which which is developed in the hoop which is bent from the straight wire. So, these are the macro stresses. Now, these macro stresses can be relaxed. So, you can they can be basically measured by the relaxation techniques using strain gauges. So, whatever the macro stresses are there, they can be measured from those techniques. So, we have the strain gauges and then we measure. So, there are many methods So, and they will be covering a large number of crystals. So, you are measuring over the area. So, normally you calculate the average stresses which the stresses which you calculate they are the average stresses which we get in the case of the micro stresses. Then comes the micro stresses. Now, micro stresses basically arise due to the heterogeneities due to differences in the elastic modulus, coefficient of expansion, etc. So, basically they are the small scale stresses, that is why it is known as the micro stresses. So, they are the small scale internal stresses, and they will be arising due to these heterogeneities due to the difference in the elastic modulus, because you have many components and they have the different properties like elastic modulus or the coefficient of expansion. So, you have different phases which are there. So, and they all will be expanding and they all will be contracting. So, as the temperature goes up or it comes down. So, because of that there will be mismatch in these values of these coefficient of expansion or elastic modulus. So, because of that because of the difference in these microscopic constituents of the material, these micro stresses are developed. Now, they also develop as they also are developing in the polycrystalline metal, and that will be because of the non isotropic behavior. Okay. So you have the crystalline grains. So their non-isotropic behavior will be also developing these micro stresses. So that is normally during the process of heating. So or you have the straining due to the chemical or due to the chemical change. So in these cases you have the development of these micro stresses in the polycrystalline metal. So you will have the interactions between the grains, and accordingly these micro stresses are developed. Then they also are developed because of the metallurgical transformations. So of the individual constituents. So that is maybe by different processes, like you have precipitation, you have phase change. So these are the examples of the micro stresses. So just as an example, that when you are getting the ferrite cementite lamellae, so when that lamella is formed at that particular temperature, that is in equilibrium with the matrix at that temperature, but when it will be coming to the room temperature, when the temperature will drop, in that case you will have the large amount of stresses which are logged into. So that these type of stresses which are logged in, they are the example of the micro stresses. Now coming to the residual stresses in the welds. So that residual stresses in welding arise due to the differential heating of plates by the weld heat source. So that is because of so that results into the non-uniform plastic deformation and cooling. So this way you have many reasons, because you will have the non-uniform plastic deformation and then cooling. So that will be produced because of like hindered contraction and expansion of the heated metal. So this is known as the mechanical stresses. So when you have the hindrance to the contraction and expansion of the heated metal, because many a times you have the equipments or the phases which are there. So you will have them as the different expansion as well as the contraction. So so because of their hindering nature, as they are attached to each other, you will have the stress development inside, and that is known as the mechanical stresses. Then you have the phase transformation. So during the phase transformation also, as there is transformation of one phase to other, and the other phase has the different properties. It has different crystallographic parameters, like it has different dimension of the unit cell. So that way in those cases due to the phase transformation you will have the development of stresses. So that is normally happening, because in most of the cases you have, if you talk about the steel, so normally we are having all the processes above the in the range of austenitizing temperature. So you have the austenite above certain temperature, and then we are cooling it. So after cooling you have the formation of different phases, like if you take the if you take the example of say iron carbon diagram. So in that case what we see, so you have you go to so you are going to this zone. So so at the top again you have the this is so this way it comes. So here that will come. So this zone, so that way it will go there. So it is on this scale. So, now you are going into this zone. Now, if you go are into this side, so this is your 0.8% carbon. So, this is carbon percentage and this is your temperature. So, when you are on this side, so basically what you see is you have this is the perlite and this side you have the cementite. So, that way you are the formation from this austenitic zone, when it is coming below this temperature, then you will have the formation of perlite and the austenite, cementite on this side. Similarly, when you are in the hypo zone, so in the hypo zone you have once you come below this temperature, then you will have the austenite which is here. So, this is a zone of austenite plus ferrite. So, you will have ferrite coming out and this side you will have the perlite. So, that way you will have on both sides, one side you have ferrite and another side you have perlite. So, cementite again is precipitating out. So, that way these transformation which is occurring and both all these phases, different phases have different properties. So, because of these metallurgical transformations the stresses which are built in, which are developed. So, that is known as the metallurgical stresses. So, that is because of the different type of metallurgical transformations or phase transformations. Then you also have the development of stresses because of the restraint to the thermal expansion and contraction offered by other part of the structure to which the piece is being welded is attached. So, many a times we attach the pieces which we are welding to different to the sides. Now, when we do the welding, so as the temperature will increase, so the temperature will increase, so the material will try, or the dimension of the specimen will try to increase because of the expansion properties of the material. So, depending upon its expansion coefficient, the material will try to increase in the length and when it will try to decrease while cooling again it will try to further decrease in length because of the decrease in the temperature. Now, if you are giving the constraint on the sides, you are giving the restraint on the sides, then that there will be stresses which will be generated inside the material because it's not getting the free hand to expand. So, you will have the specimen will be subjected to some kind of tension or compression, because it will try to expand and it is it is stopped from there. So, it will be under the compression type of thing because it is going, and so that way. And similarly, in some case it will try to come closer, or it will its length will be thinking of length will start decreasing, but then that is also restrained because of the restraint from the two sides. So, in those cases these restraint which is provided, these restraints also result into the different kind of stresses. So, because of that the stresses which are found, so that or which are generated, they are known as the reaction stresses. So, basically you have three kind of the residual stresses. One is the mechanical stresses, another is the thermal stresses, and you have the reaction stresses which we come across in these cases. So, we must have the way to control these residual stresses, and there are many ways you have to have those precautions to control these residual stresses. So, the controlling of for controlling of the residual stresses, there are different points. So, first is that you must be have appropriate type of design. So, structure should be designed appropriately. So, basically you will have you should have the appropriate type of joint, so that you get the minimum amount of residual stresses. So, basically what we do is a double V groove butt joint should be used instead of single V. So, that way we do the balancing. So, if you have to have the joint, suppose you have the chance of single V and you have the chance of as case of having a double V. So, if you look at these these two joints, so in that case the double V joint will be having more balanced structure. So, that way you can prefer for the proper design having the double V type of joint. Then the second reason what we can do is we can have, so because these are caused because of the thermal strains. So, so if you reduce the amount of weld metal, so many a times, because if you have the weld metal is in a large volume, in that case the thermal strain which is generated that will be larger. So, you should try to have the weld metal so that there is reduction in the amount of the weld metal. So, that will also lead to the lower value of the residual stresses. So, that is why you should have the reduction of amount of weld metal. So, that results into the lower value of the residual stresses. So, it results into what you can so for example, you can have the use of U groove instead of the V groove. So, that results into reduction of the amount of the weld metal. Then comes that the assembly and the welding sequence which is followed. So it should be keeping the joint basically joint fixity to minimum. So, the assembly and welding sequence should keep joint fixity to minimum. So, this this proper welding sequence and assembly should be maintained, so that the joint fixity is the minimum. In those cases the residual stress which is generated, so that can be ensured that there will be lesser amount of the residual stresses. Then you can have like you have the different type of welding processes, like if you have the long butt joint. So, various type of welding sequences are there, like you have the backstep welding is there, then you have built up cascade and all that, all those phenomena are there. So, these are basically used to reduce the residual stresses. So, in welding long butt joints, so you have the various welding sequences, like so you have the various welding sequences like backstep, then you have block, you have built up all that so they should be used should be used. So, this is used with an aim to reduce the residual stresses, and then because we will also discuss about the effect of the residual stress, because that also leads to the distortion of the workpiece. So, if that is reduced, then the extent of distortion is also reduced. Then if we talk about the multi-layer welds. So, what we do normally that in the case of multi-layer welds, we normally adopt the practice of pinning. So, basically when we go for the multi-layer welds, so in those cases all layers except the root and face of the multi-layer welds of appreciable fixity. Should be basically pinned. So, what we do is that in those cases as we go on giving the layers one by one in those cases, in the case of multi-layer welds. So, there this is a common practice to have the pinning of the layers. So, if you go to the next layer, we do the pinning, and then further we go to the next layer. So, we deposit the next layer. So, that basically reduces the residual stress to a large extent. Then we have also to see that so the next point will be, so you have we have discussed about the 5 points. Then what happens that we should avoid when while we are talking about the appropriate sequence of welding and all that, we should also avoid in any case the bending stress which are likely to be formed. So, so basically the introduction of bending stress in welding should be avoided. So, basically you should have while we talk about the assembly, or while we talk about the sequence, at that time we must have this thing in mind, that the bending stress should not be developed. Then also what is also important is that the selection of the electrode and for the material which you are welding, that also should be selected very carefully, because if there is a change in the properties of the materials which is used for the electrode, which is vastly different from that of the material which is to be welded, in those cases there is a likelihood of the development of stresses. So, material of objects so the specimen and electrode should be selected carefully. So, because accordingly because if there will be changes in the properties of the materials, so that way you have you must have the at the most possible the uniformity in the materials. And then for also for the as far as the process is concerned. So, when cracked tack welds should be chipped or melted out. Before welding the work. So, if you have the cracked tack welds and the cracks are basically very much a stress raisure. So, in those cases they will be chipped, so that cracks should be chipped off, or else it should be melted, that there should not be any crack. So, if the crack is there, that leads to the development or the increase in the value of the stresses. So, that is another way of decreasing or controlling the residual stress values. So, this is about the residual stress and its control. Thank you very much.